Dear students, so today we learn about Fischer esterification reaction. So in which ester is from the reaction between carboxylic acid and the alcohol. So this is known as Fischer esterification reaction. So we'll take one carboxylic acid, okay, and one alcohol, H. Okay, so I'm taking here acetic acid and ethanol. When these two reacts in the presence of an acid to give, we call it mineral acid. Okay, so this two reacts. So here will H, and from here it will OH will come out. So we'll start writing from here. So it will be CS3, C double bond O, here O. Okay, then next point of contact will be here. So it will be CH2, okay, CH3. So this ester has been formed. So this reaction is known as Fischer esterification reaction. In this reaction, the side product will be the water. Okay, so from here OH and H will mix the water as a byproduct. The next reaction is Hell-Volhard-Zielinski reaction. In this reactions, we'll introduce the halide group in the alpha position of the carboxylic acid. Okay, so we'll write this reaction. Suppose if we take this carboxylic acid, okay, to OH. Okay, so remember this is your functional group COH. That means the next carbon. So this carbon is your alpha carbon. This carbon is your beta carbon. So in this reaction, when you add chloride or bromide, okay, halogen, in the presence of red phosphorus. Now what will happen is that this one of the H will replace by Cl. So mono substitution takes place at alpha position. So our product will be CS3, CH, here will be Cl, okay, so C double bond O, OH, plus side product will be HCl. So what we see here is that, so any carboxylic acid which has alpha hydrogen can undergo this reaction. It is called Hell-Volhard-Zielinski reaction. We call it HVZ reaction. The next reaction will be the Hoffmann Bromamide reaction. It is commonly known as by the step down reaction. So here the amide will be converted into primary amine. So for example, if we have this amide NH2, so this is amide. When this reacts with bromine in the presence of 4 molecules of NaOH, okay, so it gives, so you have to remove here, so this carbonyl group. So you just omit it, then CS3, NH2 will be the product. So CH3, NH2 plus Na2CO3 plus 2 NaBr plus 2 molecules of water. So this is basically the step down reaction. So here this will remove. So if you count the total carbon here, it will be the 2 carbon. Now in the product it is just simply 1 carbon. So this is basically known as step down reaction. I'll take one more example. So example number 2. Suppose if we have C2CH2C double bond O. Another, I'm taking the another amide. Sorry, it's 2. Another amide. When it reacts with this Br2 and NaOH. Instead of Br2 NaOH, sometimes it can be written as a NaOBr. Okay, when these two reacts, one of the product forms is this one. So this will react with this amide to form. So you have to remove this one. So your product will be CS3, CH2, CH2, NH2. So remember, this is your primary amine. Plus side product will be there. Okay, 2NaBr plus N2CO3 plus 2 molecules of water. So this is basically step down reaction. So just count the number of carbon 1, 2, 3, 4. So here will be 1, 2, 3. So if in the later on in the conversions, if you require to reduce one number of carbon, then you have to proceed this Hoffmann Bromamide reaction. It is also known as Hoffmann Bromamide degradation reaction. Okay, or we call it as a step down reaction. The next reaction is Gabriel Phthalimide reaction. So this reaction is basically used for the preparation of primary amine. Since the yield is very good, so we prefer to do this reaction for the preparation of primary amine. So the starting product is the phthalimide for this. So it's quite easy one. So C-double-bond-O and H. So same group here. Okay, so this is our phthalimide. Okay. So when this phthalimide is treated with KOH, what will happen is water will be released from OH from here and H will be from here. So K will attach here. So it forms an ionic bond here. So our product will be, next product will be C-double-bond-O. Here is N, here C-double-bond-O. Okay. So here is a minus K plus. Okay, ionic bond. So when this sodium salt of phthalimide is treated with alkyl halide, suppose CS3CH2Br, what will happen that K will take out this B and this CH2 will attach with the nitrogen. Okay, so I am writing the product here. C-double-bond-O and C-double-bond-O, and here is CH2CH3. So this CH2 will get attached to the nitrogen. Okay, minus, I can write here KBr because K plus and Br minus will come out from here. So when this is treated with base NaOH, what will happen is like, okay, you have got like this. So the product will be CS3, CS2, NH2. Okay, and side product will be CONA, CONA. So our side product will be C-double-bond-O, ONA, and the C-double-bond-O, ONA. And our main product is this one. So that is CH3, CH2, NH2. So this is primary amine. So in the Gabriel Phthalimide reactions, we use phthalimide, then it is treated with KOH. Okay, then I have already told you that K will come here, OH will come out. So water, it's ionic one. Okay, so potassium salt of phthalimide, when this is treated with alkyl halide, then this compound will be formed. Then when it is treated with NaOH, then our main product, that is primary amine, is produced. This reaction is very important because the yield is very good. The next reaction we will learn about is the coupling reaction. In the coupling reaction, normally dye has been formed. Okay, so we call it azo dye. In the coupling reactions, we normally start with benzene diazoenium salt. So when this benzene diazoenium salt is treated with phenol, so this is the para position. Okay, so now this nitrogen gets attached with this hydrogen, okay, to form a dye in the presence of base. So our product will be N double bond, and then the phenolic group is there. Okay, so this is known as para-hydroxyazobenzene. Para-hydro. azobenzene, and this is your orange color dye. This reaction is normally used for the detection of phenolic group. Okay, if the orange color dye is formed when this compound phenol is react with this benzene diazoxide salt, then we can say the compound is phenol. Okay, so if the unknown compound is there, if it reacts with the benzene diazoxide salt and it forms a yellow color dye, then we can say that compound may be the phenol. Okay, so in that way it is later on used for the detection. The next example of coupling reaction is, so when this benzene diazoxide salt and triple bond and is plus Cl minus, the Cl is actually stays here, plus when it reacts with your aniline, it's H, it is NH2. Okay, so here also Cl and H will come out and it forms a plate coupling. So our product will be azodie and NH2. So this is para-amino-azobenzene and it forms a yellow color dye. Yellow color dye, right? So this can be used for the detection of aniline. The next reaction is iodoform reaction. So this is one of the very important reaction. It is also used in the detection of the compound. So in this reaction, iodoform has been formed. So the required condition for this reaction is the presence of this group. We call it methyl ketone. This, or it should have this also secondary alcohol. Okay, with this format. Okay, OH has to be in the second carbon, so CH3, CH, or even ethanol. So it's a CH2, CH3, CH2, OH. Even ethanol. These three compounds, this compound or these two types of compounds can undergo iodoform reaction. Okay, so we'll do the iodoform reaction here. Suppose if we have this compound, ethanol. Okay. We call it acetaldehyde. Ethanol. So remember this has CH3 C11O group, right? So this, it exactly matches here. So it has this group. So when this is treated with iodine and NaOH, I2 plus NaOH, then what will happen is that just remove this one. Okay, you think bond will break here. And this will form your iodoform. So iodoform is CHI3. So it's a CHI3 plus. Side product will be, you have to start from writing on this side. Okay, so H C11O O and A. So this is iodoform. So iodoform. So it is a yellow color crystal. Okay, so once the yellow color comes, so we can say that okay, iodoform has been formed. Similarly, I'll take another example. If we have a group like this, it's basically ketone. This was aldehyde, the ketone, but it has this group, right? So CH3COO group. Okay, so when this reacts with iodine and NaOH. So I told you that you have to, this will form your iodoform. So CHI3, so it's a yellow pipette plus side product will form. So you have to start from writing from this side. So it's a CH3 CH2 C11O O and A. Okay. So similarly, if we have ethanol or we have a group of this one, CH3 CH2 okay, OH, CH3. So I have a secondary alcohol. Then when it's treated with this iodine and NaOH, the mixture of this results in the formation of NaOI. Okay, sometimes we can also write NaOI. It's same thing as this one. So here also same side CH3, then you can choose for either side. So if I choose this as to be the iodoform, so CHI3, remember yellow, pipette. Then the remaining compounds which you have to write is starting from this side. So it's a CH3, C11O, O, N, E. Okay? So this is known as your iodoform reaction. Thank you.